Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8, Unit 8, Lesson 1. Our first question here is, which shaded region is larger? Explain your reasoning. Just took off the headphones. Okay, looking at these two regions, we have to think about how much space they take up. This first one can be broken up into triangles pretty easily like that. And each of those four triangles is the same size. It has a base of 2 units, a height of 1 unit. Area of a triangle is base times height over 2. 2 times 1 is 2, divided by 2 is 1. So that has an area of 1, that has an area of 1, that has an area of 1, and that has an area of 1. Now let's look at our other shape. This is a square. However, this square is made up of triangles that are very similar to the triangles over here. They are actually congruent. A 2 by 1 triangle, and there are 4 of them. Each of those has an area of 1 unit, and one additional in here, which has an area of 1 unit. This has a total area of 4, and this one has a total area of 5. Which shaded region is larger? It has to be B. Our next question over here says, decomposing to find area. Find the area of each shaded square. Our first square here is not easy to directly find the area. We can't tell this length. It looks like it's about 1, 2, 3, 4, 5, 6, 7, 8, 9. This looks like it's about 9 units, but it's slanted, so it is not a 9-unit length. So we can do a couple things here. We can break up this square in a similar manner to what we did over here, or we can find out the area of this whole box. This outer box has a side length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This outer square is 10 by 10. The area of that is then 10 times 10, which is 100. That's the outer square. If we want the inner square, we can take that outer area and subtract these unshaded triangles. We know how to find the area of a triangle. Base times height divided by 2. Each of these triangles looks to be the same. They are 1, 2, 3, 4, 5, 6, 7, 8, 9 units by 1 unit. 9 times 1 is 9, divided by 2 is 4.5. How many triangles just like that are there? There's one here, one here, one here, and one here. 4.5 times 4 is 18. So now we know the outer area is 100. The inner area has to be the outer area subtract these 4 triangles. 100 subtract 18 is 82. So what is the area of this square? It's 82. Now, let's try and quickly do that same area the way we did this one up here. This can actually be broken up as an inner square and 4 outer triangles. The area of this inner square is 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8. 8 times 8 fell on the floor, picked it up, it was 64. Now we have these inner triangles we can find, which are 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1. We already did that before. A 9 by 1 triangle has an area of 4.5. And if we look, this triangle here and this outer triangle here that are white, the white one and the blue one are just 2 halves of this 1 by 9 rectangle. That's where our area of a triangle formula comes from. If we had a rectangle with this base and this height, the triangle is half of it. So we know the area of these 4 blue outer triangles is 18. So if we do 64 plus 18, what do you suppose 64 plus 18 is? 82 again. So the area of this shaded triangle is 82 square units. Here are a couple more for us. We again have a 10 by 10 outer square. This one has a much different inner triangle piece. These triangles here are, well, if this whole thing is 10, that's half. 5 by 5. If we have a base of 5 and a height of 5, 5 times 5 is 25, divided by 2 is 12.5. How many of them are there? 1, 2, 3, 4. 12.5 times 4 is 50. What was the area of the whole outer space? 100. 100 subtract 50 is 50. If we try and do this one the other way, that divides pretty nicely into 4 triangles. 5 by 5. Each one of these will again have an area of 12.5. This one has a shaded area of 50. Now this one doesn't have any lines inside. It'll be a little trickier. Let's just go with the area of the outside. Well, if this is 7 and this is 3, 7 plus 3 is 10. That outer area is 100 again. Now the area of this triangle here is 7 times 3, which is 21. 21 divided by 2 is 10 and a half. 10 and a half times 4, because there are 4 of those, is 42. So the area of these outer triangles is 42. If we subtract those, we wind up with an inner area, a blue shaded area of 100 subtract 42, which is 58. So the area of this one is 58. Are you ready for more question? Any triangle with a base of 13 and a height of 5 has an area of 65 over 2, because 13 times 5 is 65 divided by 2. Both shapes in the figure have been partitioned into the same 4 pieces. Find the area of each piece and verify the corresponding parts are the same in each picture. There appears to be one extra square unit in this figure on the right. If all the other pieces have the same area, how is that possible? Well, this is a little misleading. This one's kind of tricky. This whole figure and this whole figure are not actually triangles. If we think this is a horizontal line and this is a vertical line, the slope is not quite the same for the orange as it is for the blue triangle. They are very close, but they are not the same. This blue one has a rise of 3 and a run of 1, 2, 3, 4, 5, 6, 7, 8. 3 over 8. And this one has a rise of 2 and a run of 1, 2, 3, 4, 5. 2/5 and 3/8 are definitely not the same number. This blue and orange triangle don't have the same slope, which means this is not a straight line. There's a little tiny bend in here, and that is where that extra space for that one extra square comes in. Little bit of a trick question here. Okay, our next question is estimating side lengths from areas. What is the side length of square A? What is its area? Well, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 5 by 5. Oops. Area 25. Side length is 5. What is the side length of square C? Make sure you're reading the question. It did give us the other nice one first. What is the side length and area of square C? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The area, you can count them out, but if it is 6 by 6, the area is 36. The side length is 6. What's the area of square B, and what is its side length? Well, this one's a little trickier. We can use the methods we saw earlier of enclosing it. And now we have a 7 by 7 outer square. 7 times 7 is 49. Now, what size are our 4 inner squares? Well, these are 1, 2, 3 by 1, 2, 3, 4. 3 times 4 is 12. Divided by 2 is 6. There are 4 of them. 6 times 4 is 24. So to find that area of square B, 49 subtract 24 is 25. Which means, what is this side length? Let me move this up a little more. Sorry about that. You couldn't read the question. Area and side length of square B. Well, if this has an area of 25, what do you think the side length of a square with an area of 25 is going to be? Cough, cough, hint, hint. It's already right here. Area is 25. Side length is 5 again. So this square and this square are the same square. They are congruent to each other, just rotated slightly. Find the area of squares D, E, and F. Which of these squares must have a side length which is greater than 5 but less than 6? So let's do what we did before. Enclose this in a nice horizontal, vertical square. What is our outer dimension? 1, 2, 3, 4, 5, 6. 6 by 6 is 36. What are these triangles? 1, 2 by 1, 2, 3, 4. 2 by 4 is 8 over 2 is 4, which means there are 4 of them. 4, 8, 12, 16. 36 subtract 16 is 20. So the area of square D is 20. Okay. Which of these squares must have a side length that is greater than 5 but less than 6? Well, we know that the square with an area of 25 from the last problem had a side length of 5. So this square is smaller, so its side length must be less than 5. Okay, E, enclose it. What's the size of this outer square? Well, if this one had a height of 6, this one has a height of 7. 7 times 7 is 49. What is the size of each of these squares? Height of 2. 1, 2, 3, 4, 5. 2 times 5 is 10. Divided by 2 is 5. Area of each of those triangles is 5. 5, 10, 15, 20. Subtract 20. That gives us an area of 29 square units. Now F. Enclose it again. No, sorry about that. That one got a little sloppy. If this one had a height of 7, this one has a height of 8. 8 times 8 fell on the floor, picked it up. It was 64. Now, what about our smaller outer triangles? 1, 2, 3. Height of 3. 1, 2, 3, 4, 5. Base of 5. 3 times 5 is 15. Half of 15 is 7.5. Area of all of them, 7.5 times 4 will be 30. So the outer square is 64. Each of these add up to a total area of 30. The area of square F will be 34. So, find the areas of square D, E, and F, 20, 29, 34. Which of these squares must have a side length that is greater than 5 but less than 6? So if we look back at our previous question, a square with an area of 25 has a side length of 5, and an area of 36 has a side length of 6. So for this side length to be between 5 and 6, the area has to be between 25 and 36. Well, what I see right here is two squares, E and F, with an area that's between 25 and 36. So the side length of both of these has to be between 5 and 6. Our next question is a handout and cutting out squares. We're not going to do that as part of the video. Following that, we have our summary. The area of a square with side length 12 units is 12 squared, or 144 units. The side length of a square with an area of 900 square units is 30, because 30 squared is 900. Sometimes we want to find the area of a square, but we don't know the side length. For example, how can we find the area of square ABCD? ABCD. One way is to enclose it in a square whose side lengths we do know. Outside square EFGH has a side length of 11 units, so it has an area of 121 units. The area for each of the 4 triangles is 1/2 8 times 3, so 12. So the area of all 4 of those together is 48 units. To get the area of the shaded square, we take the area of the outside square and subtract the area of these 4 inner triangles. So the area of the shaded square, this blue square, is 73 units. Thank you for tuning in. This has been another episode of Mr. Boskin Does Some Math. See you next time.